Hello. Today, let's derive one of the most useful kinematic equations, v squared equals u squared plus 2as. To do this, we need to express acceleration in terms of position. Starting with the definition of acceleration, we know that equals dv by dt. Now, we can use the chain rule from calculus to rewrite this. We introduce the position variable, s, by writing a equals dv by ds multiplied by ds by dt. Notice that ds by dt is simply the definition of velocity, v. Therefore, substituting v back into our equation, we get the elegant result, a equals v multiplied by dv by ds. Now that we have the expression a equals v dv by ds, we can complete our derivation. Let's rearrange this to group the terms, a multiplied by ds equals v multiplied by dv. To find the relationship between displacement and velocity, we integrate both sides. On the left, we integrate acceleration a with respect to displacement s from 0 to s. On the right, we integrate velocity v with respect to dv, from initial velocity u to final velocity v. Since acceleration a is constant, it comes out of the integral, leaving us with a multiplied by the integral of ds. For the velocity term, the integral of v is v squared over 2, evaluated from u to v. Let's complete our derivation for the final kinematic equation. Looking at the steps on the screen, we begin with our integrated expression, a times the quantity s minus 0 equals v squared over 2 minus u squared over 2. Next, we simplify the left side, which gives us a times s equals the common denominator expression, v squared minus u squared, all over 2. To clear the fraction, we multiply both sides by 2, resulting in 2as equals v squared minus u squared. Finally, by rearranging the terms to solve for the final velocity squared, we arrive at our well-known kinematic equation, v squared equals u squared plus 2as. We are looking at a practical application of the kinematic equation, v squared minus u squared equals 2as. In our experimental setup, we have a cart moving between two photo gates. Let's look at the data we have recorded. The final velocity, v, is 3.0 meters per second. The initial velocity, u, is 1.0 meters per second. The displacement, s, between the two photo gates is 2.0 meters. To find the acceleration, a, we rearrange our formula to a equals v squared minus u squared divided by 2s, substituting our values, that is 3 squared minus 1 squared divided by 2 times 2.0. This simplifies to 9 minus 1 divided by 4.0, which equals 8 divided by 4. Therefore, the acceleration of the cart is 2.0 meters per second squared. That concludes our lesson for today. Thank you for watching. This content is brought to you by the Ekalavya educational channel. Remember to keep learning and keep growing. If you found this helpful, please support our channel by liking, sharing, and subscribing.